I want to first begin by telling probably what everybody already knows, and that's that our current treatment for advanced stage cancer using chemotherapy alone has been relatively ineffective. So my approach has been a metabolic approach. And there are several physicians like myself in different parts of the world that are really looking at the metabolic approach to the treatment of cancer. And we think it may be more effective. So let me start by telling you about a study I did at University of Miami about 2 years ago. As you're probably aware, most cancers feed excessively on sugar or glucose. And when they process that sugar and they bring all that sugar into their cells, they process that sugar through glycolysis. The end product of glycolysis is lactic acid. So the more aggressive the cancer is, the more hypermetabolic it is, the faster it feeds on sugar, and the faster it makes lactic acid. Well, if the cancer cell is going to stay alive and reproduce, it must pump that lactic acid out of its own cell. There are 7 different mechanisms that have been discovered that get overexpressed by the cancer cells to pump its own acid out of the cell. So just to recap, as the cancers become more aggressive, they take in more sugar, they process the sugar rapidly through glycolysis, they make a lot of lactic acid, and then they must pump that acid out of the cell. Now, we talked about 7 different pumps. What I did at University of Miami is I took breast cancer cells and I took neuroblastoma cells and I bathed them with 2 drugs that block 2 of those 7 pumps that pump the acid out. My goal was to block the ability for the cancer to pump out acid. In 24 hours, we saw 30% cell death. And that cell death correlated with an increasing intracellular concentration of lactic acid. The bottom line is the cancer, the more they fed, the more acid they made, and they couldn't get it out of their own cells. Well, I took the remaining live cells, and I kept those pumps, those 2 acid blockers, blocked with those 2 drugs, but I fed them. I put them in a high sugar medium or a high glucose medium. And in 24 hours, we saw 50% cell death. And when we checked the intracellular pH, sure enough, the cancer cells became more acidic. So what was happening, if we blocked a couple of those pumps that pumped the acid out, and we fed the cancer cells, they weren't smart enough to say, I better not eat so much because I'm going to make acid that I can't get out. So it was a very exciting idea. And what I did from there is I went to Bogota, Colombia, and I started experimenting on terminal patients. And we came up with some very, very exciting findings. So now let me begin this lecture. That should set this up. And what I'm going to do is I'm going to go over a few of the pumps involved. And then what we'll do is we'll summarize at the end, and I'll give you a few case reports of patients who've been treated with my methodology. Well, one of the things, first of all, I coined the term cancer pH manipulation therapy because my goal is to manipulate the pH both intracellularly and extracellularly in cancer. But let's address this question. What about alkalinizing? I'm sure many of you have heard you need to eat alkaline foods, you should drink alkaline water, cancer can't live in an alkaline pH. Some of you may have heard of Dr. Simoncini in Italy, who talks about cancer being a fungus, which, by the way, I don't agree with, but he talks about killing cancer with sodium bicarbonate. Well, is there any validity to alkalinizing cancer? There was a landmark study, as you can see, in Cancer Research 2009. Bicarbonate increases tumor pH and inhibits spontaneous metastases. This was a wonderful study. Having trouble with this remote. Okay. The extracellular pH of malignant solid tumors is acidic in the range of 6.5 to 6.9, whereas in normal tissue it's 7.2 to 7.5. And we know why it's acidic, because the cancer is pumping the acid out of its cells. Mathematical models of the tumor-host interface and in vivo measurements have shown that solid tumors export acid into the surrounding parenchyma. Previous in vitro studies have shown that tumor cell invasion can be